Okay, we will go through the exemplar problems in the class 11 physics, chapter 5 laws of motion. Okay, before going through it, I will show you there is something called apparent weight. Okay, so when you are in the elevator, the acceleration of the elevator also matters when you are computing the weight. Okay, an elevator is at rest, the apparent weight will be the mass into gravity mg. Okay, but when the elevator is moving, suppose elevator is moving downwards, the apparent weight will be mass into gravity minus this acceleration of the elevator, that is a. When it is moving up, the apparent weight is mass into gravity plus the acceleration of the elevator. See, this gravity minus acceleration and moving down, moving up, gravity plus acceleration. Okay. Now, if we have two vectors A and B, you want to find the resultant vector A minus B. Okay, A minus B. So, as per that vector rules, A minus B is equal to A plus minus B. A plus minus B, that is A minus B. This is B and this is minus B. So, the resultant vector will come here. Okay. So, you have two vectors. When you find A minus B, the resultant vector will be. A ball is traveling in the uniform, these are the keywords, uniform translatory motion. Translatory means all the bodies of that object have the same velocity. Okay, uniform means constant velocity. Okay, constant velocity means acceleration is 0. So, this means that the all parts of the ball have the same velocity, magnitude and direction. This velocity is constant. Okay, this is the answer. A meter scale is moving with the uniform velocity. Again, this implies that because uniform velocity, acceleration is 0, so the acceleration is 0, force will be 0. So torque is also 0. Torque is nothing but a rotational force. Okay. The force acting on the scale is 0. Torque acting on the center of the scale is also 0. Okay. Torque is force into rotational displacement. A cricket ball of mass, okay, this many grams, has a initial velocity and the final velocity. After hitting it, the change in momentum. Change in momentum is given this final momentum minus the initial momentum. Okay, that is the change in momentum. So here we are converting the gram to kg. Okay, the change in momentum we are using kilograms. Okay, so 5.3. Okay, this is the momentum is mass into velocity. So mass into final velocity minus mass into initial velocity. So mass into, so we are coming, this is 0.150 kg. Okay, 150 gram to kg, and this is the equation and this is the answer. Okay. And here we are finding the magnitude of that momentum. Okay, so this is the magnitude. This is the answer, and this is the magnitude of that same thing. conservation of momentum on a collision between the two particles can be understood from this both the Newton's second law and third law. Page 11. See, this is the consideration of law of momentum. So this is derived from the second law, and here we are using the third law. Okay. So from second law, and this is from the third law. Okay, hockey players. So moving the north suddenly turns westwards. So with this same speed to avoid the anaplan, the force. Okay, so velocity. So as I already mentioned, how you see the subtraction in the vector a minus b equal to a plus minus b. Okay, 5.6. See here. So this is the final momentum westwards. So the initial momentum north. So final minus initial. Okay, that is so final minus initial. Final minus initial means so final plus minus of initial. So that is why so north will become south. So this is the final and this is the initial and this is the direction. Okay, south east. Southwest, sorry, not east. Okay, so this is the internal force, this does not matter. Okay, only the external force will be taken care. Okay, these options are cancelled. So the external force, we are choosing this option, second law. A body of mass accelerating is the force acting on this at t equal to 2 seconds. 7. Okay, this is x of t, and we are finding the velocity and double differentiation, then we are finding the acceleration. Okay, first differentiation, displacement differentiation, we get velocity, then differentiation of velocity we get the acceleration. Okay, force is equal to Fa, we found the acceleration, then we are finding the force. Okay, a body of mass 5 kg is accelerated upon by the force. Okay, the time actually just velocity on the y-axis 8. X component is just is y-axis only 5.8. Okay, force equal to mass into acceleration, acceleration equal to force by mass. Okay, so now we are computing the velocity. So here we are taking only the we are going to find the time. So we are using the other values except t, and we are taking this only one component, x component only, equal to 0, then we get that value time is 10 seconds. Okay, so this formula here we are using the final velocity, initial velocity plus acceleration time. We are using this formula. A car of mass m start from the rest and acquire the velocity on the in 2 seconds, assuming that car moves with the uniform acceleration. Okay, uniform acceleration here. The force exerted on the car is 5.9. Okay, here also we are using this same formula. So here we are finding the acceleration. From the acceleration we are finding the force. Okay. The motion of a particle of mass m is given by the x equal to 0 in this period, and this is between this period, and this. Okay, which of the following statements is true? 5.10. Okay, they given the x of t equal to, so we are doing the differentiation to find the velocity, and we are doing one more differentiation of that velocity differentiation to find the acceleration. Okay, now we are finding the force. So acceleration at only 1/8, t equal to this. Okay, so this much is the acceleration at t equal to this 1/8, and force is this. So these are the answers. Particle is not acted on upon by the constant force. Okay, the coefficient of friction between the floor and the body B is 0.1. Body A, this is much, a force F is applied as shown. Okay, force is applied, and the opposing force is this frictional force. The mass of A is m/2, mass of B is m. Which of the following statements are true? Okay, there is a frictional force Fa, so the bodies will move together if this is the force is greater than these two forces. Okay, equal to greater than or equal to these two forces. So then the body will slip if it is more than Fa plus Fp. (0.45 mg). The body will slip with respect to B if F is equal to 0.1 mg. So the maximum F is 0.45 mg. I will show you. what you will rest at, okay, this is less than that frictional force. The maximum value F for which, okay, this is 0.45, more than that is 0.5, this will slip. So NB 45.11. Okay, this is the FB frictional force, FA force A. So the acceleration is same for both the things. So this is forward force F, this is frictional force. Acceleration, this is the mass of B, mass of A. So after simplification, we are getting the acceleration. Okay. Acceleration is same. The force on A equal to mass into acceleration. Mass of the A is m by 2. Acceleration is we just found. Okay. Acceleration is the. So after simplification, this is the force on A. See, if force on AB is less than or equal to frictional force of A, FA less than or equal to the frictional force of A. Okay, so then force on A this, and this is the frictional force on A, frictional force on A. Mu is 0.2, mass of A m by 2. Okay, from that we can find the what is FB. Okay, frictional force. Okay. Frictional force on B, mu 0.1 into mass into gravity. Okay, the 0.15 mg is the FB. F equal to FB equal to, so then you will substitute, you will get this is the maximum force. 0.45 mg, FA plus FB, okay, that is 0.25. okay, so here we have 0.25, 0.45 is the maximum, 0.25 FA plus FE, then we will move together, and it is greater than the maximum, then it will slip. Mass is moves, okay, 14. Okay, you can go through this example. What is this sin theta component, cos theta component of the mass? Okay. Wide of 13. So here you see mentioned this is frictionless plane, this side. So there is no frictional constant here in this side. That is okay. So this is the answer. Two clear balls, okay, each of mass moving in the opposite direction with the speed, okay, collide each other and rebound with the same speed. If the collision lasts for 10 seconds, which of the following 5.14? Is this the momentum? We are converting 50 gram to the kilogram, 0.05. Okay, mass into velocity. So momentum. This is the final momentum. Mass into velocity, opposite direction. Okay. So because after hitting, this is the opposite direction. Change in momentum equal to the impulse, that is the final momentum minus the initial momentum. So this is the change in momentum. The impulse import, okay, this one, and this is the answer. A body of mass is acted on two perpendicular forces. They result in acceleration of the body. Okay. Five dot 1.5. Because it is a perpendicular. Two perpendicular forces, so a 90-degree angle. 90-degree angle, see cos 90 is 0. Okay, theta, so this will get cancelled, this term. So it will become like this. See, after simplification and finding the force, we will let this, okay, theta 1, theta 2. A girl riding bicycle on the straight road with this speed throws a stone of this weight and this speed with respect to the ground, the direction of the motion. The mass of this girl bicycle, okay, they are asking whether the bicycle change the velocity. Page 11. Total momentum, that is law of conservation of the momentum. Okay. Yes, due to the principle of the conservation of the momentum, initial momentum is this, final momentum is, there is a change in velocity, okay, of the bicycle. 16. This is 16, that is the law of conservation of the momentum. That is the final momentum minus the initial momentum, that is a change in momentum. Initial velocity of the cycle 5 meter, final velocity of the stone is 15 meters per second. initial this is the mass of the cycle, stone mass. As per the law of conservation of the momentum, this is cycle plus stone initial velocity equal to the cycle mass, and the velocity is not known. This is the stone mass into velocity, and you simplify, you will get the final velocity of the cycle. So that is 0.1 less than the initial velocity. So there is a change in the velocity of the cycle. A person of mass 50 kg on the vehicles on the lift. See, as I said, on the lift the weight will vary whether it is moving upwards or downwards. This is the downwards. With this much acceleration, what will be the resulting weight? Okay, 17. Because it's downwards, mass due to gravity, mass into gravity minus mass into acceleration. Okay. So we will get this, and the reaction is the apparent weight. So here they are given directly given the formula. You can see. The position time graph of a mass 2 kg is given below. What is the impulse at this? So here at t equal to 0 is a rest. It is at rest. So impulse means change in momentum. So here it is 0 because velocity is 0. So here there is something is there. So here 80. So at t equal to 0, we have the momentum 0, but at t equal to 4, we have some velocity. That is 0.75. That velocity from the slope we can make out. Okay, change in so this is the one tan theta, that is the slope. A person driving car suddenly applies the brakes. Seeing a child load on the, if he is not wearing the seat belt, he show the answer 5.19. The only retarding force that acts on him if he is not using the seat belt comes from the friction exerted by the seat. So this is not enough to prevent him moving forward when vehicle is brought to a sudden halt. The velocity of a body of mass is a function of time. Okay, this is the velocity equation. Find the momentum and the force acting on it at this second. Okay, 5.20. This is the one we have to do differentiation to find the velocity. Okay, mass into velocity is the momentum. Okay, momentum, then force is the mass into acceleration. momentum and the force. Okay, 20 zone 21. A block is placed on a rough horizontal surface pulled by the horizontal force. Let A be applied to it. Plot the show the answer. This is the when the force increasing, this frictional force also increasing. See, after some time, then the block will start moving. Okay. Now there is a constant friction. F remains constant if F increases beyond this point. This is that frictional constant mu. Why the force linear objects are wrapped in the paper show? Okay, 5.22. Okay, you can go through this transportation vehicle. Okay, just is to object can travel some distance. Draw. Why does a child feel more pain when she fell down on the hard surface or cement floor? Okay, fell down the soft this ground. 5.23. Okay. The mud floor yields and the body travels some distance before comes to the rest. Woman throws object of 500 with the speed of this means what is the impulse? Change in momentum. Okay. 5.24. To convert gram to the impulse and gram to the kilogram, we have to convert 5.24. Pay this much. Where mountain roads are generally made winding upwards rather than going straight. Okay, friction is equal to frictional constants R cos theta is the force of friction. If theta, the angle made by the slope, is small, force of friction is high. Okay, and there is a less chance of skidding. A road straight up will have a larger slope. Okay. Okay, a mass of 2 kg is suspended with the thread here. AB. Okay. The lower thread is pulled gradually harder and harder in the downward direction so as to apply force on AB. Which of the threads will break and why? 5.26. AB will break first because force on the upper thread will be equal to the sum of the weight of the body and the applied force. Weight of the body and applied force. So force on this thread will be more because this weight on the body and this is applied in this. In the above given problem, if the lower thread is pulled suddenly, that is a jerk, what happens? 5.27. If the force is large and sudden, thread CD breaks. Because of CD is jerk, the pull is not transmitted AV instantaneously. Okay, because it is sudden pull. Transmission depends on the classic properties of the body. Therefore, before the mass moves, CD breaks. So suddenly means the CD will break. This will. Two masses 5 kg and 3 kg is suspended with the help of a massless inextensible strings as shown. Okay, these are massless inextensible strings. Calculate T1 T2 and the whole system is going upwards with the acceleration of this 5.28. Okay, 5 kg, 3 kg, T1, T2, and here T1 minus 3G equal to 3. Okay, this is upward and this is downward. So T2 they are computing. Similarly, this is downward and this is upward force. And after that they are finding out the T1 and T2. A block of weight 100 newtons rests on the frictionless inclined base 30-degree angle. Flexible cord attached to the frictionless pulley is connected to the block weight for which the system is in equilibrium. 29 equilibrium. There is a condition for the equilibrium. At equilibrium, so we have this mg sin 30 equal to the force, that is the forward force. Sin 30 is 30, it's a half, sin 30 is half. So F equal to this much we are getting. A block of M held against the rough vertical wall by pressing it with the finger. If the friction coefficient of the block is mu, the acceleration due to the gravity is g. Calculate the minimum force required to be applied so that the block against the wall. 5.30. F is F equal to N is the normal reaction of the wall and the back. The minimum is this much. See, 100-gram gun fires, this much, and find the recoil velocity, that is the back velocity. So the answer 5.31. So 31. This is what they are given. You can also refer to the net for the details. Given two graphs of the diagram particle moving acceleration. Here this is the constant displacement. So acceleration is 0 here. If the particle has a mass of this much, 32. Here they have given the answer. You can go. So here again the elevator accelerating upward with the acceleration, okay. Tosses a coin vertically upwards with the speed of this much. After how much time will be okay? So here we have to consider the acceleration of the elevator also. So they are using G plus A. This is velocity equal to initial velocity plus acceleration into time. From that equation they are doing it, okay. But instead of gravity they are adding the acceleration of the lift or the elevator also. Three forces if this okay. The body is bound to move in the uniform speed. So that the forces are coplanar, okay, they are in the same plane. Since the body moving with no acceleration because the uniform speed, there is no acceleration. Forces is 0. Compare sum of all the forces is 0. Okay, so you can go through this. Torque also, force is 0, torque also is 0. So you can actually this for the long answer type, all the answers are given in the this exemplar answers details, so you can go through it. Okay, so this is the important thing, 5.40, that also they given the answers. Here how they are splitting the vectors, adding vectors, so that you will learn while going through this answer, 5.40. Okay. Okay. So you can remember these important formulas.